Parts 2 and 3 last night you had of August 2017. Parts 2 and 3 I suggested. So I'll first start out class by answering anything from parts 2 or 3 that maybe gave you some trouble here. All right. Victoria, start us off.
34.
All right. What with 34 gave you some issues?
I got the wrong number and I made I don't know where I went wrong. I think that it's when I found the.
All right, well, let's start with from the beginning because basically, in a nutshell, so we don't have to read through everything in this problem, we had a square poster within a square frame. What was the area of everything? So this, if I shaded it in, we're talking everything here. What's this full area? All right, so I'll listen to you first, and then we'll talk numbers. What'd you try to do first?
I misunderstood the question and I found the areas separately. I found the area of the poster and then I also found the area. That's what I did wrong.
Okay, well, if you found the area of both, should be an easy fix, and just do what with the two? Just add them together.
Yeah.
Parts 2 through 3. Here we go. Keep it going. Anything else? Parts 2 through 3. Going. Going. Or topics. Anything here? We don't really say much in here, which worries me a little bit, but hopefully you'll pull through. Parts 2 through 3. Yes, Sarah. Hi. Or topics. Go ahead. Coordinate proof? You got it. I'm going to have to go to, actually, you don't have that. Oh boy, here we go. We're going to have to dig into an old exam. I'm trying to, there's a exam where you had to prove it was a nope. You had to prove it was an isosceles triangle first. Then you had to find a fourth point that made it into a parallelogram. I want to say, what are we on now? August 2017, January 2018? Maybe. There's one part 3 or part 4 question where first you have to prove it's an isosceles triangle, and then from there, find a coordinate that makes it into a parallelogram.
Yes,
January, look at that. Guy knows his exams. January 2018, everybody.
It was part 5.
5, there's no part 5.
Part 4, that's what I meant. Sorry, I only saw the Z.
You may have done it. I don't think we've done it as a class. I've only done that one in my regular geometry class. So I haven't done it in any honors yet. You guys might have done it on your own, which is what you should be doing, but we haven't done it as a class. Okay, there we go. So if you haven't done it, it might be a good idea to get those coordinates set up. -1, 1, 2, 3, 4, 5, 6. -4, 1, 2, 3, 4, 1, 2, 3, 4, 5. and 5, -2. 1, 2, 3, 4, 5, -2. I got P, A, and T. Let's connect those bad boys. Here we go. Boom. All right, here we go. Prove it's an isosceles triangle. What formula am I going to need? There's only one you can use here, and that's distance formula. So we're going to have to find the distance of two of the sides and make sure they match. And this is why, even though it says the graphs are optional, this is why it's good to graph, because you could probably tell which two sides are going to end up being congruent. And that saves you a lot of time by not having to do the third side. So we're going to do PA. I'll do PA first, distance of PA. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 2, 3. 11 and 3 you get inside. I don't know if you want to check me on that. You get 11 and 3. Oh boy. 121 and 9, 130, square root of 130 for PA. Then I'm assuming it'll be equal to AT, but let's just check using distance formula. Distance of AT. 7 and 9. 81 and 49. $1.30. What'd you just learn? It's going to go in step 2. We just found out that PA, you didn't find out it was isosceles yet. PA congruent to AT because distances are equal. And then in step 3, you can say this bad boy is an isosceles triangle. So triangle PAT is isosceles because two sides congruent. We good here? What did we discuss yesterday about how we're setting this up? Yeah, organize the darn thing. I'm not reading it. Number your steps, just like it's a statements reasons proof. What? No, I have to sit there and look, but not going to be too happy, which may mean, hey, if this is a 4-point question and you didn't get all of it right, it might be a 2 instead of a 3 points. But and if I can't read anything, there's nothing I can do anyway. Sarah, you good so far? Because there's I don't care about, like, this part should be easy points, however many points this part's worth. This is easy points. It would be the next part I might be a little concerned about. And that is finding a new point. What are we going to call that? R, so that this becomes a parallelogram. So I need point R in PART, so that's a parallelogram. Now, hey, PA, so R's got to be somewhere over here because the letters go in order here. PART, so R's got to be somewhere here, and it's got to be a parallelogram. All right, properties of a parallelogram that might help me here.
Sides are
opposite side. Probably that's for us. Opposite sides parallel is what's going to do it. Could you do opposite sides congruent? Yes, but then you're just randomly putting a point and seeing using distance formula so many times to see if they're going to be equal.
Well, you want to make sure.
Well, you could check it that way, but opposite sides parallel is going to get me there a heck of a lot quicker. All right. What side do you want to find the slope of? Because if that's what we're talking about, parallel, we got to find slope. PT or PA? Okay, go ahead. Find the slope of PT. Up and over how many? Up 4 over 4 over 6. So whatever I have for whatever R is got to be, AR also has to come out to be 4 over 6. How am I going to get there? From where, though? Like, I need direction here. From A, not from T. Could I go up 4 over 6? So from point A, you're telling me go up 1, 2, 3, 4 over 1, 2, 3, 4, 5. 6. And there is point R. And, you know, you have 2 hours before you can leave, so I would just be on the safe side and say, hey, I know PT and AR have the same slope, but what about PA and RT as well, just to confirm that that is actually a parallelogram. Okay, so what is point R? Because that's the ultimate question here. Over 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 9. So that's what we would be looking for, 2, 9. That's the second part of the question, right? Where does it say that? Oh, there it is. Okay. Now we got to prove it's a parallelogram. So I'm not going to do that part with you, but tell me the different ways I could do it. How do I show it's a parallelogram? Here we go. Opposite sides parallel. What's formula would I need for that? Slopes. So I could go opposite sides parallel. Let's go. What else? Opposite sides congruent. I would need distance. And remember, also think about too what work you already did. All right, you've already found some distances, so maybe that's the way you want to go, so you don't have to find out new numbers from formulas. What else could I do? If you're Grace, if you're feeling crazy, yep. One pair of opposite sides, congruent and parallel, if you want to show off. Because then you would need what formulas? Slope and distance, if you wanted to show off. And everyone always forget. I personally think it's the easiest way, and nobody ever does it because I don't think you guys remember. Diagonals bisect each other. And what do I need to show to prove diagonals bisect each other? Show, listen up here. How do I show in a parallelogram two diagonals bisect each other using slope, midpoint, or distance? Midpoint, show both diagonals have the same midpoint. Personally, I think that's the easiest way, but it's your call. But that's how you prove the diagonals bisect each other. They have the same midpoint. Good there, Sarah? Okay. And now let me tell you, I'm going to be the happiest guy in Gym A if part 4 is a coordinate geometry one. My guess would be it's not, though. Why? Because it's the easiest out of all the proofs, and June is the one where everybody takes the exam. So why not? And every level takes the exam, including the best kids. So why not try to challenge in June? August, it's the kids trying to get a better grade or the kids that failed. So we'll give probably a coordinate proof in August. But who knows? Who knows? I don't know. I have no idea. I don't want to try to get your mindset it's going to be this type of proof because I have no idea until about 2 minutes before you walk into the room. So, and that's because I looked at it. Partition, sure. Why don't we keep that exam out? Because I'm sure there's a partition one in there somewhere. I don't know if we did it or not. Partition is just like you're completing the square. It's going to be there. And you know it or you don't type deal. I'm sure in the multiple choices, there's a partition one. Yes, no. Anybody see it? There you go. Number 6. Number 6 is the partition one. All right, let's get it going. I don't know why or what goes through the mind, but the fact that they added a graph to this one just throws kids for a loop. Usually you're just, look, here are your points, do it in this ratio, find it, we're done. The fact that kids just went nuts because they gave a graph. The only thing you should use the graph for is at the end to make sure the point you pick is actually on there and looks to be in a ratio of 1 to 2. Speaking of 1 to 2, that means I'm going to cut it up into how many congruent parts? 3 congruent parts. Starting with the x-coordinate, what's our starting? I cut it off, but what's our x-coordinates here? -5 to 4. That's a distance of what on the x-axis? 9 units. That's perfect because 9 is divisible by how many we got to cut it up, which is 3. So that tells me I go 3 units every time I want to cut it up. How many times, though? I just want to go once. So I'm only going to go 3. If that was a 4, I'd multiply it by 4. If that was a 10, I'd multiply it by 10. What was my starting x-coordinate? -5. So I'm going to go -5, add 3 to it on the x-axis, and where do I end up? -2. We could stop there because it is multiple choice, and only choice 1 has -2 as its x-coordinate, but that's not how we roll in honors. And plus, this could easily be a part 2 question. All right, what y-coordinate did we start at? 2, and we traveled to -10. 2 traveled to -10. What's that a distance of? 12. Some of you may want to put -12 because you're going down, but that's up to you. All right, just remember you're going down, not up. So I'll keep it -12. Get this bad boy out of here. So that's equal to -12, also divisible by 3. So that's -4. And here's what I want to eliminate. You do not multiply this by 2 because it's the second number and you think you go with the y's. It is always the first number for x and y. You guys are in honors. I'll explain this. If I wanted to go 2 to 1 here, that's if you go backwards from C to A. If you started at C instead of starting at A, then you would multiply by 2. All right, you always start with the first number for x and y. So from 2, I'm going to subtract 4, and I'm ending up at -2. And again, just make sure your point, -2, -2 is on that line. -2, -2, good. It should be closer to A than C because it is a ratio of 1 to 2. Could you get away with slope, cutting it up into thirds? Sure, you could. Divide it up into 3. No problem there. Yes, Marin, here we go. Now I'm taking questions from January 2018.
I forgot to ask. I put a question mark next to it.
What was the question?
It was like
14?
14.
Yeah, what about it?
Like line dilation.
Yeah.
So
Whoa. Before we start, where are we dilating around?
the origin.
Okay, that means slope's going to stay the same. Y-intercept, I just multiply by whatever the scale factor is to get the new line.
Okay.
Good? Okay. If you dilate around the origin, the slope of the line stays the same. Y-intercept, new y-intercept can be found by multiplying by whatever the scale factor is, in this case, 5/3. Well, if the point's on the line, you tell me what happens. Stays the same. I haven't, if it doesn't, I haven't seen this, but I'll go over it because you've got to prepare you for everything, right? Let's make this up. Actually, I'm just going to clear this bad boy out. Let's say I wanted to dilate this line around that point. Not on the line, not the origin. So I'm like, oh boy, I don't know what happens now. So what I do is I take 2 points right now. So I'll start with this one. I'm going to say dilate it by 2. All right. So that means this point's going to get further away from that center point, right? So over 1, down 1, 2, 3. Over 1, down 1, 2, 3. There's the new point. I'll just call it A prime. Well, actually, I don't want to call it A because that's up there. But there's the new point. Just 1, 2, 1, 1, 2, 3. 1, 1, 2, 3. And I'm going to do the same thing with another one. And then I'm going to take the slope of that line. And then I'm going to plug one of the points into y equals mx plus b to find the b value. And I got the new line. So just find 2 new points and then create the equation off those 2 points. Emily, yeah. How are we doing there? Yes, I would do it one more time. Correct. And if it was half, I'd take whatever this was. So over 1, down 1, 2, 3. So I'd go over a half, down 1.5. They probably wouldn't give you those cruddy numbers, but that's what I would do to cut it in half. All right, let me go back. Oh, topics, that's where we're on right now. Topics, anything else before we go? Multiple choice is where you're going to do well, correct? Multiple choice. Got to kill it on the multiple choice. All right, here we go. August 2017, the one we've been working on here for last night. And cold hard facts. An extra copy is on Aspen, correct? And whatever extra copies I have over there, you're more than welcome to. But once they run out, that's it. Before we start, anybody want to? You can be honest with yourself or with your classmates here. Anybody want to give what they're predicting for themselves on this Regents exam? Okay. What? I don't know what you got last year. A guess? 86. 92.
I'd say 84. I'd say anywhere between 0. I got it 98. Wow, Dylan.
Anybody think they can be the second 100 of this my tenure? And I say second, it feels like that's bad that I've only gotten 100, but I'm talking like this exam that's only 4 years old. There used to be a ton of 100s in the they changed algebra, they changed algebra 2, so they changed geometry, and then so. Like sine, cosine, tangent, we never taught that in the old geometry class. That was in algebra 2. Or maybe algebra 1, I can't remember. Grace, go ahead. Yes, Grace, you got the floor. I'm ready. The algebra 2 Regents, which you'll be taking a year from now, but go ahead, yes.
Isn't there like an insane curve on it or something?
For the lower portion, yes. But the better you do, the less it helps you out. Just like this, yeah, there is, but it's the worst one of all 3 exams.
Actually, like, what do you have to do to pass this one? Last year, wasn't it?
I don't know. I don't even worry about it because none of my students should even come close to that. But I think it's, if this test is like, say, 86 points, maybe the passing is high 40s. That's a 65. I think somewhere it doesn't help you at all. I can tell you that. I don't think, no. It doesn't have to be curved at all. It doesn't have to be curved at all. But I don't. You can't. Yeah, not in here anyway. Molly. Next year, no. I'm actually super excited because I'm adding a 3rd class of honors geometry next year, which puts me in a predicament because I don't know how I'm going to play the Survivor game next year.
Just do 2 people every.
Wait, did you ever invite into objects?
Oh yeah,
Yeah, I decided not to. It's not. I didn't hide it for the other class. It's just it didn't exist this year.
Oh.
I was really ready to.
There's, if you want to know, there's 4 people left. You're voting tomorrow for a winner because we are getting down to 3 tomorrow.
Wait, who's last?
I'm not good at last names at all, but Colin, Ella, Emma Cheney, Grace Burke, Colin M, and Ella Trainer. But one of them is going to be eliminated tomorrow, so. No, I teach Algebra 2, but to seniors over, they take the course over 2 years instead of 1.
That's possible.
Yeah, my sister did that.
Yep. Anything else here before we get to the multiple choice about math questions anyway?
Wondering if you'd like to hear about how my Algebra 1 Regents was weird.
What?
So, I had to.
I didn't respond to your question
Okay.
because my answer was a definitive no.
Oh, okay.
Oh, Alice.
But thank you anyway.
Mr. Carlito, can we have 10 questions too?
Nope.
I have one in particular I'd like to ask.
Nope.
You didn't answer it, too.
I'm good.
What?
I'm good.
If you guys can pick one person out.
No, I'm good. There's no questions here. There's no questions here. Got your cold hard facts and question 4 ready to go.
Oh, it's under my foot.
Here's a question you can answer for me. Which class is going to have the higher class average on this?
Actually, no, honestly, I'm calling it down. Unless Phoebe fails again. Or if I fail, I'm sorry. Yeah, you can put. I think Ash is serious. I second that. I got a higher grade than you, even though it was like 3 points. So like whatever. Yeah, 3 points higher though. So yeah, 3 up to you. So when you get a 96 on a class, yeah, that's right. You're nothing. Yeah.
Okay, here we go. Number 4. See if you guys can pull through.
No.
All right, I'm going over this one. It's an easy one, but not unless you know the theorem. And that is if 2 chords are parallel, something happens in a circle. And that's why I have your cold hard facts out. If you don't know off the top of your head, let's look it up, because chances are you'll remember it. And here's where I'm going to start calling on some people. If 2 chords are parallel, what's going on in the circle? Here you go. 12. Want to start us off? What's going on in this circle? Nice job. Yes. Now, again, preparing you for everything. Let's say you wanted to throw that in a proof. What would I write in the reasons? Well, what were you given? No, I need more specific. You're in a circle now. Parallel chords imply congruent arcs. Okay, parallel chords imply congruent arcs. Now this is pretty easy, I think. That's 130. We're trying to find arc AC. What are you going to set up and solve? What equation can I set up and solve? Let's hear from 11 now. What equation can I set up and solve?
Oh, it's me. I did 180 minus 130.
Yep.
And then.
Okay, time out. Where'd the 180 come from?
The semicircle.
Yep, that's a diameter. Diameter. Go ahead. And then you got
50.
2x equals 50.
And then divided by 2 was 25.
Yep. Okay. Any issues there? Keep that cold hard facts open because you're going to need it for another circle question in a second. But number 7 in between.
Yeah, that was hard.
Only reason I want to do this one with you is not to solve it, but for the following. It's telling me BE and CD are parallel. If I see that, anybody know what automatically happens in this diagram, even though it will never come out and say it? The triangles are similar, and I want to go over why. What's the reason why they're similar? Other than, oh, you threw parallel lines on there. First of all, what angle do they both have in common? They have a reflexive angle A, and then good review here. Anybody remember what these angles were called? Corresponding. So by angle, they're similar. So I'm going to ask somebody in a second, can you come up with the correct proportion to solve saying their sides are in the same ratio? There is one number up there you should not be putting in your proportion. And we'll talk why not put that number in. Got anything you want me to set up? Oh, 23. Okay, hold on. 4.5 over 1. 18 over x. That's one way. Again, there's multiple ways to set this up correctly. Why do we not use the 3.5? It's not a full side. Not a full side. Can't use that. So you got 4.5x equals 18, and then we get x equal to 4.0. Is there anything on here you wanted to ask? Okay, again, another circle question. Just want to make sure we review all the theorems. Number 12. I think we're doing a good job reviewing the circles anyway. PB 3, BC 15. What's the length of PA? I'll let you, if you don't know it already, what I need to use, go ahead and look at your facts, and we'll figure it out together here. You have a secant and you have a tangent. What's the deal with their lengths? Okay, what do I want to use or set up here? Going with number 6.
Okay, 18 times.
Okay, hold on. Ready? Just explain as you go here, Phoebe. Where's the 18? Whole secant times, go ahead, times the external part equals whole tangent times its external part, which is always the same. Yes. There you go, everybody. So 54 equals x squared. Looks like we're going to have to break down a radical. Anybody biggest perfect square that goes into 54? 9. 9 times 6. We're looking at 3. Radical 6. I think I said this the other day to you guys. You don't have to have the ability to break down a radical in this case. Just do square root of 54 and find out which decimal matches it. Obviously, it's not going to be those two. Oh, but wait, what class are we in? Hey, yep, I got a bonus question. Somebody explain to me how to find angle P. No numbers, obviously there's none on there. But how do you find angle P? What would you do to, and you can use arc names here. Go ahead, Evan, shoot.
It's 1/2, and let's see, arc CA minus arc AB.
There you go. Got a minus when it's on the outside. Subtract them when it's on the outside. Floaters when you add them.
What's the difference on the inside?
Float. Well, it's either central inscribed or floater. 22. Okay, regular decagon. Okay, decagon. Anybody want to fill me in? 10 sides. 10 sides. I guess in this case, okay. That's one reason why I'm not a big fan of this. Is you got to remember decagon. What's the number of out of these 4 choices? Which one would carry it on to itself? Meaning, same decagon, same position. I go all the way around. How many degrees am I going? 360. That's never going to be an answer. All right, never an answer. But I can take 360 and do a little something with it. Because from 0 to 360, how many times am I going to see that decagon carry it on to itself? 10 times. So to find the minimum amount of degrees I could rotate it, I can divide it by 10. So minimum, I could rotate it 36 degrees, boom, get that decagon back. Not a choice. Probably won't be a choice. So if 360 isn't a choice, 36 isn't a choice, what do I keep checking? Keep rotating. So I just went 36, go another 36. Where am I? 72, not a choice. Another 36, another 36 until I hit one of these choices up here. And it would be 252 degrees. So don't expect 360 as a choice. Don't expect the minimum number as a choice. Questions from you guys? And we're going to end this in style and go right to the next one, number 23. Okay, area of a sector. Formula. Oh, here we go. Here we measure over.
360 times pi r squared.
There we go. Little issue on this one. My final answer has to be in radians. When I solve it in this equation, it'll be in degrees. So we're going to have to do a little converting at the end. Well, let's worry about that at the end. Let's solve for the measure right now. What am I going to plug in for the area? 512 pi over 3 equals m. That's what we're solving for here. Over 360 times pi. What's my radius here? Not 32. 16. They get you everywhere they can. They try to trip you up. Silly. Real quick, both Grace, yeah, sure. Pi d is for the arc length. That's arc length you're thinking about. Good? What's on both sides? Pi, so those are gone. 112, 512 over 3 equals m over 360 times 256, I believe.
Which is half pi.
What? It's half of what? Okay. Anyway. How am I going to get m by itself? One algebraic move now. Okay, times both sides by 360. You got it.
Oh.
256m. I have no. You got to help me out here.
Divide by 256.
I'm not ready for that yet. I got this right up here. 400. Divide both sides by 256. The measure of that angle is 240 degrees. We need to put it into radians. All right, little review here. How do I put that into radians? You don't have to think about it. It's going to be provided to you. Everyone has a formula sheet on every Regents I hand to you. Look it up right now, please. Degrees to radians. What does it say? 1 degree. 1 degree equals pi over 180. All right. Where am I going to put this 240? Put it with the degrees, right? So 240, and I'm looking for how many radians that is. I know some of you don't like that fraction or the fraction, but it's the way it's going to go. Quick peek. Your multiple choices all have what in them? Pi, right? So you probably don't want to hit the pi button on your calculator because that'll just give you some crazy decimal. So here's what 240 times, okay, 240 times pi over 180. And you guys said what's always in the answer in your multiple choices? Pi. So all you guys are doing are 240 divided by 180. That's all has to be done here. Pi, I'm not going to put pi in my calculator because I see in the multiple choices it's already there. So, and what's it reducing down to? 240 over 180. 4 over. Hey, here you go. This is what we're doing. 240 over 180. And you end up with 4 over 3. So 4 pi over 3. So that's a good example to remind yourself the radians to degrees is already on your formula sheet. Nothing you need to remember. All right, that's it. 2 more to go.